Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Chapter 4, Python Programming Fundamentals, Part 3, for the Class 11 students of Computer Science. In this video, we are going to discuss about the user input, user-defined functions, indentation in Python, rules and conventions for writing Python programs, comments, debugging and practical implementation. So let's dive in and get started. Let's discuss about the user input. While writing a program, we need to fetch some input from the user. The values inputted by the user are fetched and stored in variables. Python provides the following important functions for getting users' input. First function is the input function. In Python, you can get user input from the command line using the input function. The input function reads a line of text from the user and returns it as a string. Here's an example of how to use the input function to get user input. Example 1. Name equals input of enter your name, print, hello, plus name plus exclamation point. In this example, the input function is used to get the user's name from the command line. The user's input is assigned to the name variable, which is then used to print a personalized greeting. When you run this program, it will prompt the user to enter their name, enter your name. The user can then type their name and press enter your name, Alice. The program will then print a greeting that includes the user's name, hello, Alice. On the left-hand corner, you can see how it is practically implemented. You can also use the input function to get numerical input from the user. However, you need to convert the input to an integer or float before using it in mathematical operations. Here's an example. Example 2. Age equals int of input of enter your age. Print, you will be plus str of age plus 1 plus next year. In this example, the input function is used to get the user's age as a string. The int function is then used to convert the user's input to an integer, which is assigned to the age variable. The program then uses the age variable to print a message that includes the user's age plus 1. When you run this program, it will prompt the user to enter their age. Enter your age. The user can then type their age and press enter. Enter your age, 25. The program will then print a message that includes the user's age plus 1. You will be 26 next year. Now check the practical implementation. In Python, eval is a built-in function that is used to evaluate an expression dynamically, which is represented as a string. The function takes a string as an argument and returns the result of evaluating that string as a Python expression. The syntax of the eval function is eval of expression, globals equals none, locals equals none. Here, expression is a string that contains a valid Python expression. Globals and locals are optional dictionaries that specify the global and local namespace, respectively. By default, the eval function uses the current local and global namespace. Here's an example of using the eval function. X equals 10, y equals 20, z equals eval of x plus y. Print z. The eval function is used to evaluate the value of a string. It takes a string as an argument, evaluates the string as a number, and returns the numeric result. In this example, the string x plus y is evaluated using the current global and local namespace. Since x is 10 and y is 20, the result of evaluating x plus y is 30, which is assigned to the variable z. In eval function, note that, if the given argument is not a string, or if it cannot be evaluated as a number, then eval results in an error. Here, x plus y is not given in quotation mark, to be string. So type error is displayed in the console. Type error, eval arg1 must be a string, bytes or code object. In Python, you can define your own functions to perform specific tasks or calculations. A function is a group of statements that exists within a program for the purpose of performing a specific task. Instead of writing a large program as one long sequence of instructions, it can be written as several small functions, each one performing a specific part of the task. Let's see how to define and call a function in Python. User-defined functions can take one or more inputs, called arguments or parameters, and can return a value or perform some action. A user-defined Python function is created or defined by the def statement followed by the function name and parentheses as shown in the syntax. Def function underscore name of comma underscore separate underscore list underscore of underscore parameters colon. Docstring code block return. Here's a breakdown of each part of the def function syntax. Def, this keyword is used to define a function in Python. Function underscore name, this is the name of the function. Function names should be descriptive and follow the naming conventions of Python. Parameters, these are the input values that are passed to the function when it is called. Parameters are optional and can be one or more. Docstring, this is an optional documentation string that describes the function. It is used to provide information about what the function does, its parameters, and its return value. Code block, this is the actual code that performs the task of the function. It should be indented and start on the line after the function definition. Return, this keyword is used to return a value from the function. It is optional and can be used to return a value or object to the caller. If no return statement is specified, the function returns none by default. Here are some examples of a simple user-defined function. Example 1. Def greet of name colon. Print, hello, plus name plus exclamation point. This function is called greet and takes one argument, which is a name. The function simply prints a greeting that includes the name. To use this function, you can call it with an argument. Greet of Alice. This will print the greeting, hello, Alice. Example 2. You can also define a function that returns a value using the return keyword. Def add of a, b, colon. Return a plus b. This function is called add and takes two arguments, a and b. The function returns the sum of a and b. To use this function, you can call it and assign the result to a variable. Result equals add 3, 5, print, result. This will print the sum of 3 and 5 and displays 8 as output. You can define functions that have default parameter values, allowing you to call them without specifying all the arguments. Here's an example. Def power of base, exponent equals 2 colon. Return base raised to the power of exponent. This function is called power and takes two arguments, base and exponent. The exponent argument has a default value of 2. The function returns the base raised to the power of exponent. To use this function, you can call it with just the base argument. Result equals power of 3. Print, result. This will print the result of raising 3 to the power of 2 as 9. You can also call the function with both the base and exponent arguments. Result equals power of 3, 3. Print, result. This will print the result of raising 3 to the power of 3 as 27. Statements below def begin with 4 spaces. This is called indentation. It is a requirement of Python that the code following a colon must be indented. Practical implementation on user-defined functions. Example 1. Let us define a simple function, which does not return any value, by using the command def func1 and call the function. The output of the function will be, it is interesting to learn Python functions. Now, look at the Python code. The provided Python code defines a function named func1. The function has no parameters, indicated by empty parentheses. Within the function body, there is a single line of code that prints the string. It is interesting to learn Python functions to the console using the print function. By calling func1 outside the function definition, the function is executed, and the output. It is interesting to learn Python functions will be displayed in the console or output window, indicating the successful execution of the function. Example 2. To write a user-defined function to print a right-angled triangle. Now look at the Python code for line-by-line explanation. The given Python code defines a function called triangle. Inside the function, there are 4 print statements that print a series of asterisk in a triangular pattern. Each print statement represents a row of the triangle, with the number of asterisks increasing by 1 from the previous row. When you call the triangle function, it executes the code inside the function. As a result, the following triangle pattern will be printed. Example 3. To write a Python function to compute area of a rectangle. Now look at the Python code. The provided Python code defines a function called area_rectangle that calculates the area of a rectangle. The function takes 2 parameters, length and breadth, which represent the length and breadth of the rectangle, respectively. Inside the function, the area of the rectangle is calculated by multiplying the length and breadth together, and the result is stored in the area variable. The return statement is used to specify the value that will be returned by the function. In this case, the area variable is returned as the result of the function. Outside the function, the code print area rectangle of 40, 20 calls the area rectangle function with the arguments 40 and 20, representing a rectangle with a length of 40 and breadth of 20. The returned area is then printed to the console using the print function. So, when you run the code, it will output 800. In Python, indentation is used to indicate the block of code associated with a particular control statement or function definition. Python uses white space to delimit blocks of code, unlike other programming languages that use curly braces, keywords, or other symbols. Indentation is a key part of the syntax in Python, and incorrect indentation can cause errors or change the meaning of your code. You should be consistent in your indentation style throughout your code, using either spaces or tabs to indent each level. It is a requirement of Python that the code following a colon must be indented. Here's an example of how indentation is used in a function definition. Now look at the first Python code. This Python program is indented correctly. How do you know? In the first Python code, below the def func1 statement, we have to shift the print statement 4 spaces to the right. This is indentation. I have marked the space in yellow color. When you leave indent, that is spacing, in front of the print function, it will give the expected output. Now look at the second Python code. When we write print function right below the def function, without shifting to the right 4 spaces, it will show indentation error. You can see the indentation error, which is marked in red color. The error can be removed by making proper indentation before the print function. At least one indent is required to make your code work successfully. Thus, indentation is shifting of a statement to the right of another statement by adding white space before a statement. While working with Python, the following rules and conventions are to be kept in mind. First rule is the statement termination. The newline character is the most common way of terminating statements in Python, and it is used to indicate the end of a line of code. That is, when you end typing a statement in Python by pressing the Enter key, the statement is considered terminated by default. Second rule is clarity and simplification of expression. Clarity and simplification of expressions in Python can make your code more readable, maintainable, and easier to understand for other developers. Here are some tips to achieve clarity and simplification in Python expressions. Use descriptive variable names. Use meaningful names for your variables to help you and other developers understand the purpose of each variable. Next is, break down complex expressions into smaller ones. Instead of writing a complex expression in a single line, break it down into smaller expressions that are easier to read and understand. This can also help you avoid errors in your code. Next is to use parentheses to clarify order of operations. Use parentheses to clarify the order of operations in complex expressions. This can help prevent confusion and errors in your code. Next is to avoid unnecessary code. Remove any unnecessary code that doesn't add value to your program. This can simplify your code and make it easier to read. Next is to use built-in functions and libraries. Use built-in functions and libraries whenever possible, as they are often more efficient and easier to understand than writing your own code. Next is to use list comprehensions. Use list comprehensions to simplify the creation of lists from other lists or data structures. Next is to use conditional expressions. Use conditional expressions to simplify if-else statements, particularly when the statements are simple. By applying these tips, you can create more clear, concise, and understandable expressions in your Python code. Next rule is simplicity of instructions. Here you have to avoid complex instructions. One instruction per task should be given. Follow standards of a language. Use appropriate comments. Keep the names of the variables short, simple, and meaningful. Next rule is maximum line length. Line length should be of maximum 79 characters. Next rule is lines and indentation. Blocks of code in Python are denoted by line indentation, which is implemented using 4 spaces per indentation level. Next rule is to avoid multiple statements on one line. Although you can type multiple statements using semicolon between 2 statements in a single line, it is not recommended. In Python, comments are used to document code and provide context for other developers. Comments are statements in a script that are used to explain Python code and are ignored by the Python interpreter and do not affect the execution of the program. Let's discuss about the single-line comment. Single-line comment in Python start with the hash symbol and continue until the end of the line. For example, hashtag this is a single-line comment, can be written either on the top, right side, or bottom of the statement. Multi-line comments can be created using triple quotes, either single triple quotes or double triple quotes. This is sometimes called a docstring and is typically used to document functions or modules. Look at the example 1, how multi-line comments are used. In addition to describing the purpose and functionality of your code, comments can also be used to temporarily disable code that is not currently needed or to leave reminders for future modifications. Look at example 2. We are temporarily disabling the print hello world code. When writing comments, it is important to keep them concise and to the point. Avoid commenting on obvious code, but do comment on code that may be difficult to understand. Good commenting practices can make your code more readable, maintainable, and easier for other developers to understand. Debugging in Python refers to the process of identifying and fixing errors, bugs, and other issues in your code. Debugging is an essential part of the software development process, as it allows you to find and correct problems before they cause issues for users or other parts of your program. Errors in Python are classified into 3 types: syntax error, runtime error, and logical error. Let's discuss one by one in detail. A syntax error in Python is an error that occurs when the interpreter is unable to parse your code due to a mistake in the syntax. In other words, the grammatical rules of a programming language. Syntax errors are common when writing Python code, especially if you're new to the language. Examples of syntax errors in Python include leaving out a symbol, such as colon, comma, or forgetting to close a parenthesis or a quote. Next is misspelling a keyword. Using an incorrect keyword, such as typing print instead of print. Next is incorrect indentation. Forgetting to indent code within a block, such as within a loop or a function. When a syntax error occurs, Python will raise a syntax error exception and provide information about the specific error, including the line number and a description of the problem. The error message can help you locate and correct the issue in your code. Example of syntax error. Now, look at the Python code. For just printing class 11. Here we started with single quotes and ended with double quotes. Hence the output received syntax error, unterminated string literal. Next error is the runtime error. A runtime error in Python, or any programming language, is an error that occurs while a program is running. These errors are often referred to as exceptions in Python. When a runtime error occurs, it means that the program has encountered a problem that it cannot handle, and the program will be terminated. A number of built-in exceptions are defined in the Python library for runtime error. Zero division error, name error, type error, value error, and index error. We discuss about the types of runtime error. First one is the zero division error. Zero division error occurs when a program tries to divide a number by zero. Now look at the example 1 Python code. The code print 10/0 will indeed raise a zero division error in Python. This error occurs when you try to divide a number by zero, which is mathematically undefined. Next runtime error is the name error. Now look at the example 2 Python code. When 10 is assigned to variable a, it gets printed as output 10. But unknown variable b gets printed, name error is displayed. Next runtime error is the type error. This occurs when a program tries to use a variable or value of the wrong type. Now look at example 1 Python code. In the first print statement, two strings are concatenated, joined together, to form 22 as output. But in the second print statement, a string and a number is concatenated, which results in type error. Now look at example 2 Python code. We cannot add list and a tuple together. Type error occurs. Remember, lists are enclosed in square brackets and tuples in parentheses. Next runtime error is the value error. This occurs when a program tries to use a variable or value that is outside the expected range. Now look at example 1. In the first print statement, the float value 27.45 is converted into integer value as 27. In the second print statement, a string is converted to integer value, results in value error. Next runtime error is the index error. This occurs when a program tries to access an element in a list or other data structure that does not exist. Now look at example 2. To access an element in a list, L1 of 3 results in 44. How did we get 44? Now, look at the index table on the left side. Index starts from 0. So index 0 equals 11, index 1 is equal to 22, index 2 is equal to 33, and index 3 is equal to 44. So L1 of 3 is equal to 44. Now look at the second print statement, L1 of 7 results in index error. Since index 7 is out of range, we have values only until index 3. So the second print statement, L1 of 7 results in index error. Next error is the logical error. In Python, logical errors are errors that occur when the code does not do what it is intended to do, even though it may still run without any syntax or runtime errors. These errors are also known as bugs, semantic errors, and are often caused by mistakes in the logic of the code. Here are some common examples of logical errors in Python. Off by one errors. These occur when the code accesses elements of a data structure, such as a list or array, with an incorrect index or range. For example, if you have a list with 10 elements, but you try to access the 11th element, you will get an off by 1 error. Next one is infinite loops. These occur when the code gets stuck in a loop that never ends. This can happen when the loop condition is not properly defined or when the loop does not terminate when it should. Next one is incorrect conditionals. These occur when the code uses incorrect conditional statements, such as if, elif, and else, or the conditionals are not evaluated correctly. For example, if you use the wrong comparison operator, example, using single equals instead of double equals in an if statement, you may not get the expected results. Next one is mixed up variables. These occur when the code uses variables incorrectly or assigns values to the wrong variables. For example, if you have 2 variables with similar names, you may accidentally use the wrong variable in your code. Next one is incorrect function calls. These occur when the code calls functions with incorrect parameters or calls the wrong functions altogether. This can result in unexpected behavior and errors. In this example of logical error, we are finding the average of the 2 numbers. Now look at the code. 2 floating point numbers are inputted from the user and stored in variable x and y respectively. Now, in the third line, the order of operations in arithmetic, division is evaluated before addition. The program will not give the right answer. This is known as logical error. To rectify this problem, we will simply add parentheses, z equals open parentheses x plus y close parentheses /2. Thanks for watching. Watch the upcoming videos. Chapter 5, Conditional and Looping Constructs, Part 1, which includes introduction, types of statements in Python, program control flow, use of indentation and conditional statements. You can check the link in the description box below.